Practice free response problem 1. So we've got a 400 kilogram car slamming on its brakes while it moves forward with a speed of 10 meters per second. It slows to rest over a distance of 10 meters. So the engine is no longer applying a force, and we only have friction stopping the car. So we've got the normal force in the car, we've got the weight of the car, and we've got the friction force acting backwards. Let's balance forces. So we know the normal force balances the weight. We also know that the friction force, so we'd have 0 here if you want, minus friction makes the car accelerate. And we want to determine the coefficient of friction. So one other thing that happens is that we know the car is coming to rest from 10 meters per second, so that's V initial. And we know that it stops, so that's V final. And we know that X final is 10. And that x naught is 0. We don't know the time, so let's see if we can calculate the acceleration to start with. So we have v squared equals v naught squared plus 2a x minus x naught. And so that's going to give us 0 squared is 100 squared plus 2 times a times 10 minus 0. And so, sorry, that's 10 squared. So we're going to end up getting, again, here, 100 equals 20 times a. So a is 5 meters per second squared. Let's see what we can do with that. So we know the friction force is going to end up being m times a, and that's negative friction equals m, which is 400, times a, which is 5. And, I just realized I think I had the sign on this wrong. This should actually be negative 5 meters per second squared when we solve this, so it's negative 5 there. When we solve this, we're actually going to end up getting that the friction is a 2,000 Newton force. Now, unfortunately, we don't want the friction, we want the coefficient of friction. Remember, we want that letter mu, so we need to distinguish between the friction force and mu, the coefficient of friction. So friction is mu times n, where n is the normal force. And let's see if we can solve. So we know the normal force equals the weight, which is going to be 4,000 newtons, because that's mg, which is 400 times 10. And so we're going to end up getting that 2,000 newtons of friction equals mu times 4,000. And so I'm getting a mu value of 0.5. So in the last video, I will go ahead and finish up this practice exam.